Hello everyone. So, our today's topic is the fire protective clothing. So, extreme heat and fire protective clothing. So, the heat may be due to fire or may be due to any other source like any radiative heat. So, here we will understand the what type of protective clothing we must use, what are their construction, different layers and what are the different types of materials available at present, and also we will try to see different standards available and different measurement technique of heat and fire protective clothing. So, thermal distress, as has already been mentioned, it is of two types, due to extreme cold and due to extreme heat. At present topic, we will discuss the thermal distress due to extreme heat. So, when a person is exposed to extreme environment, extreme hot or extreme cold, the threshold limit for the normal thermal regulation system, it reaches quickly. So, our body thermoregulatory system does not work. So, this picture shows the body core temperature, which is 37 degree, which is actually normal. The environmental temperature is hot, but to keep our body temperature under control, we must wear proper thermal protective clothing. So, during extreme heat environment, if the heat loss to the environment is sufficient, that is by sweating and evaporation, then body will maintain the temperature at 37 degree Celsius. This can be done by preventing the heat to enter to our body, and at the same time whatever heat our body is generating, we must allow this heat to come out from the body. With extreme heat condition, when the outer environment is warmer than our body, so we will start receiving the heat by conduction and radiation, because conduction and radiation takes place based on the temperature gradient. So, heat will try to flow from higher temperature to lower temperature, which is our body, but the two ways to protect or maintain our body core temperature at around 37 degree Celsius is either by proper evaporation of sweat and also by preventing this conductive and radiative heat coming from environment to our body, and this can be done by proper selection of the heat protective clothing. If we cannot do so, our body core temperature will increase, and with the increase in body core temperature, we will reach to a condition which is known as hyperthermia, where body heat loss is insufficient and body will start receiving heat from environment. So, during that drop in blood pressure takes place, heat stroke and other effects will occur, heat cramp, heat rash, failure of sweat gland, which is dangerous, because sweat gland sweating is a process by which our body releases heat, and also by evaporation of sweat body releases extra heat of, that is latent heat. So, we must create a situation where the excess heat does not enter in our body, we must protect ourselves from extreme heat. So, we try to maintain our body temperature at around 37 degree Celsius through our thermoregulatory system by vasodilation. When the body core temperature increases through vasodilation, the blood flow rate increases and we increase some heat. So, these are the different phenomena what happens. As I have already mentioned, if the body temperature continues to rise, the sweating mechanism will be activated to accelerate heat loss, and through evaporation of sweat we release some more heat. Now, coming to the type of firefighting clothing. extreme heat protective clothing. There are basically divided in two broad categories. One is proximity firefighting clothing PFFC, another is structural firefighting clothing. The proximity firefighting clothing is those clothing where the firefighter is going to close to the fire, he is not entering to the fire, and the fire mainly reflective, the radiative heat penetrates to the human body, and to prevent the that radiative heat we may use reflective coating. Another firefighting clothing is that structural firefighting clothing SFFC, where a person can enter into the fire to protect human being, human life or maybe property, where the threat is much more than proximity firefighting clothing. In proximity firefighting clothing, at least 95% of heat is reflected and ensure performance of extreme heat work environment. So, we have to ensure that heat, majority of the heat is reflected out, provides ambient heat protection up to 250 degrees Celsius, but on the other end structural firefighting suit is designed to protect human being to much higher temperature, that is around 1100 degrees Celsius. So, firefighting operations include the activities fire rescue, fire suppression, property conservation, there are many other applications. So, for this structural firefighting suit, firefighter suit is useful to protect the firefighters from hot exposure where high level of radiant, convective and conductive heat are released. So, in structural firefighting mainly radiant, convective, conductive heats are there. In this case proximity firefighting clothing, the firefighters work near fire of extreme temperature. So, they do not enter into the fire. So, this firefighter clothing application building fire, gas fire, liquid fire, other situation releasing high level of radiant heat. There are some additional requirement for proximity firefighting clothing as per National Fire Protection Association NFPA, that radiant protective performance test for outer layer and intersect time should not be less than 20 seconds. So, that majority of the heat it comes through the radiative heat. So, that performance should not be that less than 20 seconds. Resistant to delamination of outer layer, adhesion durability test for outer layer and shall show no separation of coating or laminates. So, in this type of fabrics, that proximity firefighter clothing we need to have some coating, reflective coating, but during use this coating should not be removed, proper adhesion should be there, that is one of the important requirements. Also during flex movement, that is flex durability test has to be there for outer layer and shall show resistance to breakage, shatter or crack formation in coating or lamination. So, during the bending or flexing, the outer layer crack formation should not be there. So, these are the additional requirements for proximity firefighter clothing. So, if you see like extreme cold protective clothing, fire protective clothing also has three distinct layer, that is outer layer, middle layer and inner layer. Now, we will discuss the construction and importance of three layers. This is the picture of firefighting clothing, where this is outer shell, thermal liner, the inner shell, and at the middle it is a moisture barrier. So, moisture barrier's function is to allow the moisture generated during activity in our body to come out from the inner layer to out environment to keep our body dry. At the same time, it should prevent any liquid, hot water or any sorts of liquid to penetrate inside. First, let us discuss about the outer layer. So, the other terms for outer layers are thermal protective layer or reflective layer or shell layer, we can call at different terms. Reflective layer is used where we use the reflective coating mainly for the proximity firefighting clothing. The purpose of the outer layer is that it should provide resistance to ignition. So, once it is coming to extreme heat, that the outer layer is the layer which is exposed to extreme heat or fire. So, that means this particular layer should be fire resistant, it should not ignite easily and it should protect the wearer from radiant heat and flame. So, it should not ignite and at the same time it should be heat protective. As it is at the outer layer, so its breaking strength should be high because it is keeping the total structure intact. It should be resistant to mechanical hazard, like it should be cut resistant, abrasion resistant, tear resistant, because this outer layer is the layer which directly comes under different mechanical hazard. Middle and inner layers are protected and protected by this outer layer. So, outer layer has multiple functions and also it should not accumulate static electricity. There are different situations, maybe abrasion, maybe other different, it can come close to some high electric field. So, it should not accumulate the static electricity. At the same time, it should provide resistance to chemical, hot water absorption and thermal shrinkage, because this is the layer which comes directly under extreme heat, and that is why the chances of shrinkage of outer layer is maximum. So, it should be shrink proof. So, we must select the material for outer layer keeping all this requirement in mind. The materials which are used for outer layer fabric, so Nomex 3A, Kevlar, Nomex Kevlar blended material 50-50 or at different proportion it can be blended. The reason for blending I will discuss. PBI fiber and their blend, Nomex PBI, Nomex PBI of different combinations, sometimes tenolon fibers are used. If we want to have coating, so we can use aluminized coated Nomex fiber or aluminized coated glass fiber. So, these are the materials which are suitable for outer layer fabric. Now, coming to the middle layer, the middle layer means it is a moisture barrier layer, the other term it is moisture barrier layer. The main function is to allow the moisture vapor form, but it will not allow the water to come inside. So, main purpose here is to it is resistant to radiant heat and flame, provide breathability to the structure. So, it should have pores, it should avoid penetration of moisture inside the fabric from environment. So, in the form of liquid it should not penetrate inside the structure, allow some physiological heat by evaporation of moisture to pass. So, whatever evaporative heat, whatever heat, physiological heat we produce, it normally should allow to get evaporated in the form of moisture and provides comfort to the wearer. The layer should provide resistance to chemical hazard and protect the wearer from external hot water and liquid. In case of splashing of hot water or liquid, this layer should prevent the hot water or any other liquid or chemical to penetrate inside. The materials which are being used here aramid fibers and their blends or laminated with flame resistant or flame retardant material. So, aramid fibers or their blends are similar to the outer layer also. Here along with the fabric, the coating is needed to keep it breathable. So, we need to apply breathable coating, at the same time it should be waterproof, breathable coating should be there. So, this material, that coating materials are PVC, polyurethane or PES, polyether sulfone. These are the coating materials. Sometimes regenerated viscose fibers are also used, but flame retardant viscose fibers are used. PTFE with polyurethane coating materials, these are the material. So, here we should use one coated fabric and the inner layer which is actually thermal insulating layer. That is why this layer's other name are thermal liner or thermal barrier. The main purpose is that it should provide resistance to external heat. So, resistance to external heat flow through the clothing. So, from outside heat, the heat should not be transmitted through this clothing. It provides the thermal resistance, provide high breaking strength to the structure, provides resistance to mechanical hazard and chemical hazard, exhibits good thermal insulation property, provides comfort characteristics. So, materials, the similar materials are used like aramid fibers, Nomex and their blends, Kevlar, Nomex Kevlar blends, and sometime we use aerogel based aramid composite. So, aramid fiber with aerogel composites are used and at the inner layer, or fire retardant cotton and their blends are also used as the inner layer. The possible layers are shown in this table. The outer layer, inner layer, here thermal liner is used. So, at the middle layer, what I have seen, we have discussed here, the middle layer is the moisture barrier layer. The moisture barrier layer is not required for structural firefighter clothing. Moisture barrier is required for proximity firefighter clothing, because proximity firefighter clothing, the firefighter works for longer time, where moisture whatever it is generated inside body, it should come out with the time, but structural firefighter clothing is basically it is required for short span of time. So, there are different combinations one can try. So, overall desirable properties of fabrics for fire protective clothing is high heat resistant, high LOI value, it should be at least greater than 20. Most flame retardant fabrics have LOI of more than 27, high abrasion resistance, high flame resistance, low toxic gas release due to combustion of fiber. That is very important in selecting the coating material and fiber material. Due to high heat or flame, the material should not release toxic gas. That is the reason for some death occurred due to release of toxic gas, not due to heat. The material should not melt at high temperature, high tensile strength should be there at least at higher temperature, higher impact resistant, high fatigue resistance, high cut resistance, low ability to absorb moisture. So, it should not absorb moisture to a higher extent. Now, coming to the importance of thermal protective clothing, it has been observed that clothed area can burn more severely than the unclothed portion. So, the most severe burn are occurred by ignition of clothing, not by the original flash fire, because original flash fire it is for fraction of time, few seconds, but once the cloth start burning, it ignites, that will create severe burning. So, this protective clothing should maintain a barrier to isolate the wearer from thermal exposure. It should trap air between the wearer and the barrier to provide insulation from exposure. So, we should design a clothing looking at all these points. It should reduce the burn injury, it should be able to provide sufficient escape time and does not burn, melt or drip. These are the important requirement, important considerations we should make before selecting the clothing material. In addition to the protective clothing, foot and leg protection should be there, hand protection should be there, head, eye, face protection should be there. So, there are different materials which are available to provide all these requirements that has been discussed. So, most common material is aramid fiber used for fire protective clothing. These aramid fibers are made from aromatic polyamides. These aramid fibers, there are two types, meta-aramid and para-aramid. So, these fibers, aramid fibers are a class of heat resistant strong synthetic fiber used in high activity use, high end use, that like aerospace, military application, ballistic application. The chain molecules are highly oriented along the axis, hence their strength is very high there and their melting point are very high. There is a high melting point, it is more than 500 degree Celsius. So, meta-aramid is that they are high heat resistant fiber, they do not ignite and do not melt. So, these are the requirements of fire protective clothing, that is why meta-aramid is widely used in fire protective clothing production. Nomex is fiber from DuPont. So, this fiber sometime it may shrink under intense heat. For this reason, para-aramid fibers are mixed with the meta-aramid fiber. So, Kevlar when mixed with the meta-aramid fiber like Nomex, so we can get Nomex 3A, which is a blend of 93% Nomex with 5% Kevlar and 2% anti-static fiber. So, Nomex 3A is one fiber which is blended fiber. Para-aramid fibers are, they have superior tensile strength and elasticity, high impact resistance. So, for this reason they are used with high strength applications like automotive tires or ballistic applications. The Nomex, it is known for their combination of heat resistance and strength. So, they are both highly strong and heat resistant. They do not ignite, melt or drip, better long term retention of mechanical properties at higher temperature. So, they are inherently fire retardant, they do not decompose at high temperature around 400 degree Celsius. Another advantage of Nomex fiber is that once this fiber is exposed to flame or high heat, this fiber swells, that means the diameter increases, they become thicker and which makes the fabric out of that, this fiber compact. So, they form protective barrier between heat source and the skin due to compact structure. Once the fabric cools down, they become again, the diameter become again normal, it reduces, and during this swelling they give extra protection to the wearer. This is one interesting characteristics of Nomex, that is why Nomex is used for outer layer. Another fiber which is Nomex Nano, which is improved total heat loss compared to normal typical thermal liner. So, which reduces the heat stress. It shows approximately 30% more absorption capacity compared to conventional thermal liner. Kevlar is also used. So, the woven Kevlar fabric is very strong and flexible also. As far as degradation is concerned, the degradation temperature is 520 degree Celsius and maximum degradation rate is 8.2% per millimeter in air. So, it can resist 450 degree Celsius for a few minutes and at 250 degree Celsius at that high temperature at least 1 month it can retain its strength. So, at high temperature condition this fiber is useful. Next material is M5 fiber. It's actually it matches or exceeds the aramids and PBO fiber as far as their properties are concerned. Molecules have strong lateral bonding. So, they are very strong, better shear and compression resistance. Teflon is another material which is used for fire protective applications. PBI or PBO fibers, they are used for flame retardant or fire protective clothing. So, they suppress aramids in flame resistance and dimensional stability, chemical and abrasion resistance. They are sensitive to photodegradation. Xylon is another fiber used for thermal protective or flame protective purpose. Ceramic fibers are also used. The spun from organic and mineral precursor material by heating or pyrolyzing. Thermal blankets made of layers of woven ceramic fiber, and they are used for insulating purpose. So, they when we use this ceramic fabric as outer layer, they dissipate heat from molten material splashes. So, we can use ceramic fabric. Nextel is another high performance fiber which is flame resistant, used for aerospace application. High temperature insulating wool is another type of fibers. They are made from synthetic mineral and resistant to temperature above 1000 degree Celsius. There are different types of mineral wool, PCW, AESW, alkaline earth silicate wool, ASW, aluminosilicate wool. So, there are different varieties of mineral wool fiber. So, they are manufactured from basically mineral, different types of minerals. Alkaline earth silicate wool are known as high temperature glass wool. In addition to this, we can use some coated fabrics also. PTFE coated glass fiber fabrics are used for fire protective clothing or heat protective clothing. The base fabric is glass fabric, which is basically durable and it is coated with non flammable PTFE coating. So, PTFE is also excellent resistant to chemical splashes. So, they are used for mainly high temperature applications where the clean environment is required. So, PTFE coating on glass fiber, it helps in preventing the shredding of loose glass fibers, where contamination of glass fibers are basically dangerous. So, this PTFE coating prevents the loose glass fiber to come out from the structure. This is used for clean areas. So, here PTFE coating acts as sealant to stop glass fibers becoming airborne. So that glass fiber after breaking it should not come to the environment. The temperature rating of coating is minus 60 degree Celsius to 230 degree Celsius, and base glass fiber it is up to 550 degree Celsius. So, although glass fabric has higher temperature rating, but this PTFE it works up to around 230 degree Celsius. Pyrogel XT blanket, it is basically produced from aerogel, it is aerogel composite for high temperature application. Silica fabric is also used for high temperature insulator and thermal protection. Some flame resistant products are where we use normal commodity fibers, but these fibers have been developed, modified to make them flame resistant, like fire resistant viscose, and it can be blended with Nomex. Monocrylic cotton blend, these are used for fire protective application, or cotton can be treated with fire retardant treatment. These are the commodity fibers from which we can develop the fire protective clothing, and inherently fire retardant products are Kevlar, PBI, Nomex and their blends Nomex 3A as already been discussed. Now, if we have a product and we want to improve the flame resistance in the fabric stage, there are different ways to improve the flame resistance. One of the ways is that to use swelling agent, like PBI fiber or blends of two fibers. So, they are inherently flame resistant, and this flame resistance characteristics can be improved by addition of swelling agent. So, what swelling agent does? With the presence of flame, this fibers will get swelled and this will block the pores and increase the protective performance. So, polar organic solvents that have been found to be preferred swelling agents are N-methyl pyrrolidine, dimethyl sulfoxide, dimethyl acetamide. So, these are the agents which are used for as a swelling agent. So, after understanding different fibers, now we will discuss the burning behavior or skin burn or thermal environment. This diagram shows how heat is being transmitted from the source to our skin. This is the external source, this is radiative heat source, there could be flame through outer layer, middle layer, that is moisture barrier layer, thermal insulating layer, the heat is flowing and ultimately it is coming to our epidermis, outer layer of the skin, and dermis and subcutaneous fat. Once the heat is flowing through the layers of fabrics and air gap, the heat which is reaching to the epidermis, which it is important, and we must know the time required to heat flow, that is called burning time. The total the skin burn can be divided into 6 major groups. These are scales, which include the splashing of hot liquid or water or steam, which is not that dangerous, it can be recovered quickly. Contact burn, once we touch the hot object, so this contact burn takes place. Chemical burn, electrical burn, fires and radiations. These are the different types of burns. For the fire protective clothing, the main areas one should concentrate on fires and radiant heat. So, if we try to see the firefighters environment, thermal environment, that can be classified into different groups. Mainly it is a 3 groups: routine fire exposure, hazardous exposure and emergency condition. In routine exposure, the air temperature is 60 to 100 degree Celsius with the heat flux from 0.83 to 1.67 kilowatt per square meter. Tolerance time is 10 to 30 minutes. So, very high tolerance time, and that does not require any special clothing. Hazardous condition, where temperature is high, 120 to 300 degree Celsius with higher heat flux, and tolerance time is 1 to 10 minutes. In this case, we require some uniform, but not special thermal protective clothing. But in case of emergency condition, where air temperature is very high, it can go up to more than 1000 degree Celsius, and heat flow rate is very high, 12 to 200, and tolerance time is very short, 5 to 20 second, where we need special thermal protective clothing. So, depending on this exposure condition, we have to select our clothing. So, the burn injury, it results when the temperature of the skin cell becomes high enough for that, for the material enclosed by the cell wall to undergo physical changes. So, that the cell wall at that high temperature, when it goes physical change, then we will call it as burn injury. This process starts at temperature above 44 degree Celsius. Burn injury are often measured in terms of depth of burn, and it is a degree of burn. Higher the degree of burn, higher will be the severity of burn. So, the severity is measured by depth of burn. So, they are divided into 3 categories. The first degree burn, which is more common. So, most common burn type like sunburn, only the outer layer of the skin is affected, skin becomes red, no blister formation, that is the first degree burn. In second degree burn, usually result in blister and accumulation of fluid, epidermal and dermal layers are affected, and heating, that healing takes some time. Whereas third degree burn, it is very serious, here healing is not possible and cell gets totally damaged. In designing the thermal protective clothing, we must ensure the second degree burn, the exposure to flame can rapidly exceed human tissue, that is tolerance, and causes second degree or third degree burn. So, we must target to develop the flame retardant fabric which will protect us from second degree burn, and the second degree burn time is the time we should keep in mind while developing the fire protective clothing. The flame retardancy and burning behavior. So, if we apply the flame retardant, they work in different ways. To prevent the ignition by increasing the heat capacity of the material. So, if we use the flame retardant, that means the heat capacity of the material is increased. So, once the heat capacity is increased for any flame retardant material, heat capacity is more, that means it will prevent ignition. So, it will absorb the heat before ignition takes place. Flame retardant also works by formation of char, which will prevent the fire spreading. The char formation, which is actually insulating in nature. So, fire spreading stops. The additives that releases free radicals during burning, these free radicals disrupt combustion process. Fillers that release water at high temperature, so that also prevent fire spread. So, there are different blends also used. So, rate of heat release from polyester cotton blend is proportional to cotton content, but the rate of burning is controlled by the polyester. So, by controlling the blend or type of yarn, we can control the fire. Like low twisted yarn can transmit fire quickly. So, we use high twisted yarn where air entrapment is less. Loose fitting garment exhibit chimney effect. So, flame spread more rapidly up in the vertical direction in the fabric. We sometimes use protein fiber, it is difficult to ignite. So, we will stop here. In next class we will discuss the NFPA standards and different measurement techniques of fire protective clothing. Till then, thank you.